Alright, I'm in my exercise physiology book. I'm on page 79. 79, exercise duration and fuel selection. The big question was just asked. In such a workout, the emphasis is on low intensity and long duration. But is that really the best way to burn fat? See a closer look at 4.2 for the answer. We'll look at 4.2 real quick. 4.2. These are just going to be those diagrams. Exercise time. I think they meant 4.12. There's a closer look. We're going to have to read that. Alright, we're moving on. Alright, this will be page 79, exercise duration and fuel selection. During prolonged, i.e. greater than 30 minutes, moderate intensity, 40 to 59% VO2 max, exercise, the R decreases over time. So R again, let's go. And when R as the predictor of fuel utilization, R is the ratio of the VCO2 to the VO2. Alright. The respiratory quotient, respiratory exchange ratio. Yep, let's keep that fresh. Figure 4.12 demonstrates this point, the gradual shift from carbohydrate metabolism toward the increasing reliance on fat as a substrate. What factors control the rate of fat metabolism during prolonged exercise? Fat metabolism is regulated by those variables that control the rate of fat breakdown, a process called lipolysis. Triglycerides are broken down into free fatty acids and glycerol by enzymes called lipases. These lipases are generally inactive until stimulated by the hormones epinephrine, norepinephrine, and glucagon. For example, during low-intensity prolonged exercise, blood levels of epinephrine rise, which increases lipase activity and thus promotes lipolysis. This increase in lipolysis results in an increase in blood and muscle levels of the free fatty acids and promotes fat metabolism. In general, lipolysis is a slow process, and an increase in fat metabolism occurs only after several minutes of exercise. This point is illustrated in figure 4.12 by the slow increase in fat metabolism across time during prolonged submaximal exercise. Driving on. The mobilization of free fatty acids into the blood is inhibited by the hormone insulin and high blood levels of lactose. Insulin inhibits lipolysis by direct inhibition of lipase activity. Normally, blood insulin levels decline during prolonged exercise. However, if a high carbohydrate meal or drink is consumed, 30 to 60 minutes prior to exercise, blood glucose levels rise and more insulin is released from the pancreas. This elevation in blood insulin may result in diminished lipolysis and reduction in fat metabolism, leading to a greater use of carbohydrate as fuel. Alright. Interaction of fat and carbohydrate metabolism. During short-term exercise, it is unlikely that muscle stores of glycogen of blood glucose levels would be depleted. However, during prolonged exercise greater than 2 hours, muscle and liver stores of glycogen can reach very low levels. This is important because depletion of muscle and blood carbohydrate stores results in muscular fatigue. Why do low muscle glycogen levels produce fatigue? Recent evidence suggests the following answer. Depletion of available carbohydrate reduces the rate of glycolysis, and therefore the concentration of pyruvate in the muscles is also reduced. This lowers the rate of aerobic production of ATP by reducing the number of Krebs cycle compounds, the intermediates. In human muscle with adequate glycogen stores, submaximal exercise, 70% VO2 max, results in a 9-fold increase above resting values in the number of the Krebs cycle intermediates. The elevated pool of Krebs cycle intermediates is required for the Krebs cycle to speed up in an effort to meet the high ATP demand during exercise. Pyruvate produced via glycolysis is important in providing this increase in the Krebs cycle intermediates. For example, pyruvate is a precursor of several Krebs cycle intermediates. When the rate of glycolysis is reduced due to the unavailability of glucose or glycogen, pyruvate levels in the sarcoplasm decline and the levels of the Krebs cycle intermediates decrease as well. This decline in the Krebs cycle intermediate slows the rate of the Krebs cycle activity, which the end result being a reduction in the rate of aerobic ATP production. This reduced rate of muscle ATP production limits muscular performance and may result in fatigue. It is important to appreciate that a reduction in the Krebs cycle intermediates due to glycogen depletion results in a diminished rate of ATP production from fat metabolism, because fat can be metabolized only via Krebs cycle oxidation. Hence, when carbohydrate stores are depleted in the body, the rate at which fat is metabolized is also reduced. Oh, Jesus. Therefore, fats burn in the flame of carbohydrates. The role that depletion of body carbohydrate stores may play in limiting performance during prolonged exercise is introduced in the Winning Edge 4.2 and is further discussed in both chapter 19 and 23. We gotta go read this closer look 4.2. We'll do that in the next video. Alright, that was page 80, interaction of fat and carbohydrate metabolism, going into 81.